Okay, we're going to do a lot of graphing today, and so what I'm going to do is I'm going to put up some graph paper on a lot of these problems so that we can kind of go through and make it a little bit easier to see. I know you don't have graph paper with you, but just try to do the best you can with what you got. Okay, so first up, we're going to talk about what we call a linear equation. And there's several different forms of a linear equation. But if I say linear equation, what does that tell me about my graph? It's a line, right? It's going to make a line, okay? And the line can look a lot of different ways. It could have some slope to it. It could be vertical. It could be horizontal. There's different kinds of lines, but it's got to be a line. Linear equation means my graph will be a line. And there's a couple of different formats that we will see. This is the first one that we're going to graph. The generic form of this is y equals mx plus b. Anybody remember what we call this equation? Name of it?
Slope-intercept.
Slope-intercept, good. Okay, so this is what we call slope-intercept form. Okay, m is the letter that we always use for slope. You're going to see that a lot. You have seen it a lot before. Whenever we identify slope, we always use the letter m. It's just the letter that we use for that. B is going to represent my y-intercept. Okay, so m is your slope. B is the y-intercept. And we want to graph it in a specific order, okay? So when we start here, what we're going to start with is we're going to plot the y-intercept first. That's got to be my first step. We can't start with slope because we don't know where we're starting at, okay? We have to have a starting point. My starting point is going to be the y-intercept. My y-intercept is a positive 2. Really watch that sign in front. If this was a minus 2, then that would be a negative 2. But because it's positive, we know it's a positive 2. And so we're going to go up 2. Remember, the y-axis is your vertical axis, up and down. So we're going to go up 2 on the y-axis, and we're going to make a point. Okay, so that's our starting point. From there, we're going to plot m. And we're going to talk about slope later on in the chapter, but I'm going to go ahead and do it a little bit sooner than what the book does it because I feel like we've done it before, we're pretty familiar with it, plus it's the easiest way to graph it, okay? So we'll talk about slope in more depth later on in the chapter, but what we're going to do here is use the slope to plot our other point. And the reason why it's easier to do this is because it's rise over run. Okay? And I spelled rise a little bit differently. But the reason I spell it with the y is because that tells us we're going to rise first, and that's our y value. It's going to go up and down first. So the top number tells me how much we're going to rise, and then the bottom number tells me how much we're going to run. So in this case, because the top number is a negative 4, then we're going to go down 4. So from the point that we already made, we're going to go down 4, we're going to go over 3, and we're going to make a point. I can do that as many times as I want to. I can go down 4, right 3. I also could go up 4 and left 3. But when I start to look at those points, what I identify or what I see is that they're all going to make a line, right? And so now we can connect all those together and we can make a line. And that would be our graph. Okay, if it doesn't start to form a line, that means you probably have a point in the wrong spot. Really all we need is 2 points. 2 points is sufficient to make a line, but we could go as many as we need to. Another thing that I will point out, because this gets talked about a little bit sometimes, if I were to look at a point like right here, if I identify what this point is, I'm going to move left 1, 2, 3, and then I'm going to move up 1, 2, 3, 4, 5, 6. So that ordered pair right there is negative 3, 6. Okay? Now, the reason I point that out, and I could do that with any point on here, I just randomly chose that point. We have 4 of them, so I could have chose any of the 4. I could plug that ordered pair in to that equation. Remember, your ordered pair is an XY ordered pair, okay? So I could take 6 and plug it in for Y. And take negative 3 and plug it in for X. And this is just kind of a way that you could check it, right? And the reason I show you this is to show you that if I were to multiply this together, so we might think this is really hard to multiply, and obviously you could use your calculator, but it's really not that bad. Negative 4 times negative 3 is 12. 12 divided by 3 is 4. 4 plus 2 is 6, and it works, okay? So that would be kind of a way you could check your answer. You might see a question sometimes that says, does negative 3, 6 satisfy this equation? And our answer would be yes in this case. If I had a point like over here and I plugged it into this equation, that would obviously be no, because it's not going to be on my line. So in order to satisfy the equation, the point has to be on that line. Okay? And there's a bunch of points. There's not just 1 point or 2 points. There's an infinite number of points that would satisfy that equation. So there would be a lot of different things that we could check on that. Not that you have to check it, but that's what we're doing. Okay. Now, I like to graph it this way. I will also show you this, our graph. And that's the other direction we talked about, if I went up 4 and left 3. Okay. So, but what you can't do is you can't do both, right? Because if I put a negative on top and a negative on bottom, what's that going to do? What happens when I take a negative divided by a negative? It becomes a positive, right? So if I made both of them negative, that would make my slope go the other way, and that would be a completely different line. Does that make sense? Questions on that? A slope of negative 4 over 3. Sometimes you'll see that negative sign like out in front of the fraction, kind of like this. And some people ask me, where does that negative go? Well, you get to kind of choose here. You could put it on top, like we did. You could put it on bottom. If I put it on bottom, then my rise would be 4. And my run would be negative 3, which means we're going to move left 3. And that also gets us to... Okay, so that's our first one. We call that slope-intercept form. Okay, the next one is a different form, okay? And here's how we know that it's in a different form. Slope-intercept form that we just did is always going to be in the format of y equals something, right? Y is all by itself. Here, obviously, y is not all by itself. We call this one standard form. Standard form, generic form looks like this. All right, so there's good and bad to all of these, okay? Now, here's what I will tell you as well on this one is that graphing on your graphing calculator is not always ideal. On the last one, it wasn't bad. It was a pretty good option, right? Because it was already in slope-intercept form. This one's not in slope-intercept form, so unfortunately your calculators will not let you plug in an equation that looks like that. Okay? What I would have to do is I would have to solve for y. And it's not necessarily difficult. It would be a little bit of work to get there, but what I'm going to tell you is I don't think that's the best method to do that here. Okay? I'm going to show you a quick and easier way of doing it. You might have seen this before, and maybe you haven't, but I'm going to show you a really quick and easy way to graph out a standard form. That way we don't have to solve for y. Sometimes it's easy to solve for y, sometimes it's a little bit more difficult. So the method that I like to do here, whenever it's in standard form, I call it the cover-up method. And I'll explain why I call it cover-up. In order to graph a line, I must have 2 points at least. On this one, we're not going to use slope because we don't know what the slope is. That's the hard part about standard form. The A, the B, and the C here don't represent anything. They're not your slope, they're not your y-intercept, they're not your x-intercept, they're not anything that we need. Hey. Just gonna transfer it. Okay. Just and I'll get you all. So that's what makes this one difficult. Okay, so here's how the cover-up method works. Instead of finding the slope and the y-intercept, what we're going to find here are the two intercepts. We're going to find the x-intercept and we're going to find the y-intercept. Okay, so if a point is the x-intercept, that means it's somewhere on the x-axis. Okay? So if you were to tell me a point that's on the x-axis, what would be the ordered pair of a point on the x-axis? Like this point right here. What would that ordered pair be? 2, 0. Yep. And if I moved one to the right, now it's 3, 0, 4, 0, 5, 0, right? And so what do all those ordered pairs have in common? They have a 0 value for the y. So what we're going to do for the x-intercept is we're going to put 0 in for y. Because if it's a point on the x-axis, it'll always have a value of 0 for y. Here's why I call it the cover-up method. We're going to take 0, we're going to plug it in for y. 3 times 0 is still 0, okay? And because this is 0, I'm going to cover it up. We don't need it anymore. It's going to be gone. 0 doesn't really help us, doesn't do anything, right? It's just 0. So my equation is really left with 2x equals 12. Can we solve an equation of 2x equals 12 pretty easily? Yeah. All we got to do is divide by 2. 12 divided by 2 is 6. So my first point is 6, 0. Make sure you plot it on the right axis. This is the x-axis. So 6, 0 would be on that x-axis. Okay, the y-intercept is very similar. It's going to be on the y-axis. Okay, when I go up on the y-axis, this would be 0, 1, 0, 2, 0, 3, 0, 4. All of those ordered pairs have 0 for your x value, right? So when I find the y-intercept, we're always going to plug 0 in for x. When I plug 0 in for x, 2 times 0 is 0. So once again, we're going to cover it up. That's why I call it the cover-up method, because we're going to cover up the x value. Don't cover up the negative sign. That's where sometimes people get tripped up. I'm going to cover up the 2x. I have negative 3y equals 12. So now I'm going to take 12 divided by negative 3, and that would give me negative 4. So you still got to keep that sign on that 3, negative 3. And so we got to make sure that we go down 4. All I need is 2 points to graph. I've got 2 points. And once I have those 2 points, we're going to connect those 2 points together. And we got our line. Okay? And you really can't put this into your calculator unless you really want to solve for y here. Okay? And I didn't solve for y, and I'll show you one here in a second that we can actually do both to it. We have a choice of which way we want to go. So if you really wanted to put this in the calculator, you would have to solve for y. I don't necessarily think that's the best method, okay? I like to do it this way, and I think it's a little bit quicker and easier. Questions on that one? Okay, on this next one here, I'm going to show you, on this one I would say you have some options. My original equation is 3x plus y equals 6. Right now, it's in standard form, okay? And so if I see it in that form, my first instinct might be, hey, I'm just gonna do the cover-up method. And that's good, okay? If you notice that and you recognize that it's in standard form, let's see what standard form is gonna give us if we do the cover-up method. And it doesn't matter which intercept you find first, okay? You gotta find them both. So if I plug 0 in for x, I don't have a coefficient in front of y, so it's just assumed to be a 1, right? So that's simply just y equals 6. And then I'm going to cover up the y. I'm going to plug 0 in for y, so I'm covering it up. I have 3x equals 6 left. 6 divided by 3 makes 2. So we have 0, 6. We have 2, 0. And those are my 2 points. And that would be my graph, okay? And you don't have to do another method, but I'm going to show you something here too, just to show you how these two relate to one another. Especially if you really wanted to use your calculator. The form that it's in right now, I can't use my calculator, but if I really like using my calculator, which I know a lot of us do, and that's not an issue, then we got to solve this for y. On the last one, solving it for y wouldn't have necessarily been real easy. This one is pretty easy. Because all I got to do to solve for y is do what? What would I do to get y by itself? Subtract 3x. Just move this over here because we have a plus sign in between. So we got to do the opposite operation. I'm going to subtract 3x from both sides. Remember, these are not alike. One's got an x, one doesn't. So we can't combine them together. So when I rewrite this, I always like to put the x in front because that's what slope-intercept form looks like. So this would be my slope. This would be my y-intercept. If there's no number underneath on your slope, then it's always assumed to be 1, right? The one we did earlier already was in fraction form, so we knew what the rise and the run would be. Here we know the rise, the run would be 1. It's always assumed to be 1 if there's nothing down there. Okay, just to show you how these two relate to one another. The very first one that we graphed, we said we're going to start at 6, right? So if I start at 6, we're going to go up 6, and then we're going to go down 1, 2, 3, over 1, 1, 2, 3, over 1. Do we end up in the same spot? Yeah. Okay, now do I have to do that second method? Not at all. I'm just showing you that no matter what method you choose to use, I'm going to get the same graph. Okay, so it's not like if I use standard form, I'm going to get one graph, and I use slope-intercept form, I'm going to get something totally different. Those two forms are going to be exactly the same. Okay, like all the points are going to be the same, all of the intercepts are going to be the same. So you don't have to do both methods. Just pick the one that fits that equation the best. Okay, and I don't necessarily care which one that is for you. Whatever makes more sense to you. Okay, so those were all linear equations. This next one is a different kind of equation. So what is different about this equation than the first three that we did? There's a square. Yep, there's an exponent. Okay, and the exponent's a 2. So when I have an exponent of 2, anybody remember what we call that one? what type of equation that is? Linear is an exponent of 1. What type of equation has an exponent of 2? It's a summer brain drain, right? Everything's left from Algebra 2. I'm telling you, you heard this word a lot in Algebra 2, even in Algebra 1, going back a ways. It's quadratic. Good. Okay, and we talk about that because this is a really big word and term in college algebra. We're going to see a ton of quadratic equations this semester. Right now, we're just focused on graphing them, but we're going to see this a lot as we go the rest of the semester. So knowing that term. Anytime you have an exponent of 2 as my highest exponent, your equation is a quadratic equation. Okay, now, before we graph it, do we remember what type of graph this is going to make? It's not linear anymore, so it's not a line. What type of shape? It's a letter of the alphabet. U. It's a U shape, yeah. And we call it a parabola. So parabola is the name for it, but it makes a U shape. Okay, sometimes that U shape opens up, sometimes that U shape opens down. You could put this into the calculator, and I'm going to show you real quickly here. Putting this in the calculator is a great option. Okay, and use your calculator to help you out. So all we're going to do here, table of values. Okay, 0, 0 is a point. We call that point the vertex, and that's something we'll talk about more later in the semester as well. But that's the point where it's coming down, hitting, and going back up. And you could generate these on your own. Like for instance, if I plug in 0, 0 squared is 0, 2 times 0 is still 0. If I plug in 1, we got to do the exponent first. So 1 squared is 1. 1 times 2 would be 2. And this is why it makes a U shape. If I plug in -1, I'm going to plug it in place of x. But what you have to make sure of is that you do the squared first. Order of operations is the key here. So we got to square first. -1 squared is -1 times -1, which is still 1. And then 1 times 2 would be 2. So I get the same y value for both of those. So if I go over 1, up 2, and then right 1, up 2. Okay. The other one that we did was 2. 2 squared is 4. 4 times 2 would be 8. Okay, and we're starting to get really high. It would be like all the way up here for 2 and -2. But as I connect all these together, you should make that U-shaped parabola. So when I look at that equation right away, I should tell what type of graph it's going to be. Okay, because sometimes people only do like one side of it, and if you just plug these 2 points right here, then you might think, oh well, it looks like it's going to be a line. But when I start to look at more points, I realize that it's not just going to make a line. It's going to make a little bit of a curve, and then eventually it's going to be a U shape. Okay, one more thing on graphing, and then we'll do a couple of formulas here. Okay, right away, when I look at this equation, the first thing I recognize is we have an exponent of 2 again. So that tells me that this is a quadratic equation. So it's going to be a U shape. Once again, what's going to happen with this U shape? Anybody remember some of the rules that you talked about in Algebra 2? What does the negative in front of the x squared do? Yep, flips it upside down. So it'll still be a U shape, but it's going to flip upside down. The 3 is going to move it up 3. And that's just kind of looking at it and identifying how those things are going to impact the graph. Once again, you could put this in. So what I would look for on a quiz or a test is I would look for some points. And it doesn't have to be a ton of them. But on a parabola, what I would recommend is where does it reach its high or low point? In this case, 0, 3 is where it reaches its high point. That's what we call the vertex of the parabola, the high point or the low point. Okay, and then I could go like 1 and -1. and they both come up at 2. Okay, and you could keep going if you want to. Okay, 3 points is probably sufficient, kind of like with the line, we needed at least 2. With the parabola, we need the vertex, and we need a point on either side of the vertex. If you wanted to generate some more, you could. But we're just going to generate our parabola using those 3 points, and that would be our graph. Okay, questions about graphing? You guys kind of remember all that, right? We've been doing that for a long time and have seen all of those forms before. Okay, there's 3 formulas that we're going to talk about today. Each one of these go back to like a coordinate plane. We talked about graphing today, and so all 3 of these formulas are different things based on plotting points on a coordinate plane, and they do different things. So the first one, I'm going to put a couple of points up here. So we have 2 ordered pairs. And we can do a lot of different things with those 2 ordered pairs. One of the things that we're going to do is we're going to say, how far is it from point A to point B? And we did this a lot in geometry. Okay? And we can't just count. Because this is at an angle, we can't just say, okay, I'm going to start here, and I'm going to count 1, 2, 3, 4, 5, 6, or whatever it's going to be. We could maybe kind of guess about what we think it's going to be. But if it was horizontal or if it was vertical, I could just count up, or I could count left and right. I can count that way. But if it's got a slope to it, we can't count diagonally. So we have to have a way to get there. Well, the formula that we use here is the distance formula. Okay. It's been a little while since we've used that. I'm going to give you the generic distance formula. And it doesn't matter which one's which, but we're going to label those 2 points as x1, y1, x2, y2. And I could flip-flop. Okay? You'll still get the same answer. We're going to take those 4 numbers and we're going to plug it into the formula. So we're taking x2 minus x1. Really watch your signs here. We're going to do 4 minus negative 2 squared. And then we're going to do 1 minus negative 3 squared. And I'm writing the whole thing out just so you can see it, but hopefully we kind of know that, like, when I subtract a negative, what's that really going to make? This is going to make the plus. We're just going to add it. Okay, and if you wrote it out as addition right now, that's nothing wrong with that. Same thing here. 2 negatives together are going to make that a positive. So that's really 4 plus 2, which is 6. 6 squared would be 36. Over here, first of all, we got a plus sign in between these 2 parentheses. And then we have 1 plus 3 is 4. 4 squared would be 16. So we have 36 plus 16. Which is radical 52. That doesn't really tell us a whole lot, right? If I said, what's the length, if I put a board in front of you and said, what's the length of this board? Has anybody ever told somebody, oh, that board looks like it's radical 52 feet long, right? That'd be kind of silly, right? Nobody ever talks like that. But that's what we call the exact answer. And so if I wanted an approximate answer, if I was going to go into Lowe's and have them cut me a piece of board, I'm not going to tell them radical 2 feet long. I'm going to approximate and probably have a little bit extra. So I'm going to take the square root of 52, which is just a little bit more than 7, because the square root of 49 is 7. So 52 is just a little bit bigger than that. So if we type that into our calculator, the calculator should give you a decimal. Okay, what is the decimal? 7 point, how much? 2-1. Okay. And when we talk about a coordinate plane, we just talk about U for units. It's just a generic label that we use, because it's not feet or inches or anything like that. It's just units, square units. So we're saying the distance between this point and this point is about 7 units long. Does that seem about right if I was to count that? And it's not exact. Right? Sometimes it will be exact, but in this case, not so much. Okay, so that's the first thing that we can do with 2 points, is find the distance between those 2 points. The second one we're going to do here, and I'm going to use the same 2 points, but we're doing something completely different. We're going to find the midpoint. The midpoint, pretty straightforward. It's the point right in the middle of the 2 points that I have. But it has to be on that segment that we made. So I connected the 2 points together. I made a segment. The midpoint is going to be, if we just kind of estimate, about right in the middle. Okay? And so we can kind of maybe get close, but once again, what happens if we have decimals or fractions for our answer? So we don't just want to guess and say, here's the answer. We want to use a formula to get there. So here's the generic midpoint formula. Once again, we're going to have 4 values. We're going to have x1, y1, x2, y2. Notice that my answer looks a little different here because my answer is going to be an ordered pair. It's not going to be a length or a distance. It's going to be an ordered pair. So we have to express our answer as an ordered pair because it's a point that's halfway between 2 other points. Okay? I'm going to use the same 2 points that we had up above. We're going to plug that into our formula. So we're going to go -2 plus 4 over 2. And then we're going to go -3 plus 1 over 2. Just plugging those numbers from up above right into the formula. And then we're just going to do a little bit of math. -2 plus 4 is 2. 2 divided by 2 is 1. -3 plus 1 is -2. -2 divided by 2 is -1. So my ordered pair is 1, -1. And I always like to kind of look back at the picture. And if you don't draw a picture, it's okay. But I think seeing the picture here is kind of helpful. 1, -1 makes sense. That's the ordered pair that would be halfway between those 2 points. And that kind of tells me if my answer looks right or not. Okay, you guys kind of remember those two? It's been a while, distance and midpoint, but we've been exposed to both of those before. Okay, last one. Last one is, and this one might be a new one to you. Okay, this is the generic form for the equation of a circle. We're going to plot a circle on a coordinate plane. Well, when I have a circle, what are some key components of my circle? Well, I got to have a center. I got to have a point that the circle is surrounding, right? So I got to have a center, and then I have to have a radius. R is going to represent my radius. My center is represented by the H and the K. The R represents the radius. The X and Y is still an ordered pair. If you think about all of the equations that we've done today, they've all had X and Y in it, right? X and Y is part of an equation. So it would be an ordered pair or whatever, but the new part to this equation is the H, the K, and the R. And it looks like it's a really difficult equation, okay? But it's not as bad as what you think. If I gave you 5, -8, and said this is my center, and said that we have a radius of 3, this is my h, this is my k, and my r value is 3. So we're going to go, x is going to stay x minus h. Well, h is 5. Okay, so we're going to go x minus 5 squared. And then we're going to go y minus -8. And that would be y plus 8 because we subtracted a negative. We talked about that a few minutes ago. We're just going to go ahead and make it a positive. And then my radius is 3, but what we got to remember is we have to square that radius. So this would be 3 squared, and 3 squared would be 9. And that's as far as you need to go. We don't need to do any other math or anything like that. That is the equation of a circle. Okay? And you should be able to go back and forth. If I gave you this, you should be able to tell me what the center and the radius is. Here's one thing to make sure you identify is that this is always opposite of this. They have opposite signs. If this is -5, this is +5. If this is +8, this is -8. So the h and k are always opposite from the center to the equation because the sign inside of here is a minus. So that makes us change our sign. Okay. That's it. It's our first lesson. Hopefully not too bad for Friday. All right, I'm going to put the page numbers up here for you. Okay, and when I write these out, it's going to seem like a lot, but I just kind of go through and pick some problems out. It's a little bit easier than doing evens and odds. And these are just problems that I feel like you should be able to graph or to do or whatever it might be. So it looks like a lot of problems, but it's just because I'm listing them all out. Because there's 100 and some problems in the homework set that I have to kind of pick from. Okay. Yeah, John, you need to vote. Anybody else need text votes? Real quick here, I know some of you